Okay, get this. What if a flare from our sun, 93 million miles away, could actually trigger a massive earthquake and a volcanic eruption right here on Earth? I know, it sounds like science fiction, right? But a wild series of events just happened that has scientists asking that exact question. So let's unpack what's going on.
So on December 7th, three just huge things happened, one right after another. First, at 8:39 Universal Time, bam, a really powerful M-class solar flare, and that's the second highest category there is. It slammed right into Earth. Then, just 2 minutes later, at 8:41, a major 7.0 magnitude earthquake, the kind that causes some serious damage, hits the Alaska-Canada border. And as if that wasn't enough, at pretty much the exact same time, the Kīlauea volcano in Hawaii erupts, and erupts violently.
Just 2 minutes, that's it, 120 seconds. I mean, think about that. That's all the time that passed between the solar flare hitting our planet and the ground starting to shake. The timing is so tight. It's really hard to chalk that up to pure coincidence,
I mean, it really was the perfect storm of events. You've got this massive solar flare, a major earthquake, and this crazy volcanic eruption. But here's the part that makes it even more incredible and kind of spooky. All three of these things happened in the exact same hemisphere, the side of the Earth that was literally facing the sun at that moment. The chances of that happening randomly? Well, they're just astronomical.
So this is it. This is the central question everyone's asking now. Was this just a cosmic fluke, a total 1 in a billion coincidence? Or is there a real physical connection between what the sun does and what happens to the ground right here on Earth?
I mean, this idea, it really challenges everything we thought we knew about geology, right? We all learned that stress builds up on tectonic plates and that's what causes earthquakes. But what's that final little push? What's the trigger? Could that tiny nudge really come from all the way out there, 93 million miles away?
Okay, so to even begin to answer that, we have to look at this really fascinating and, pretty controversial idea. It's called the electromagnetic trigger theory. And basically, it suggests there's a physical pathway for the sun's energy to actually reach down and influence stuff happening deep inside the Earth's crust.
And the whole process starts way up high, in a layer of our atmosphere called the ionosphere. The easiest way to think of it is like the electrical skin of our planet. Now, when a ton of radiation from a solar flare smacks into this layer, it just supercharges it, making it way more electrically conductive. And that's the first link in the chain reaction.
So here's how the theory goes, step by step. First, that solar flare radiation ionizes the atmosphere, just like we said. That creates these really powerful electrical currents. Second, those currents can actually flow down, penetrating into the Earth's crust. And third, if one of those currents happens to hit a fault line that's already stressed out and ready to go, well, it could be the tiny little nudge that finally sets it off.
Now, this is a super important point, so let's be clear. The sun is not creating the energy for the earthquake. That would be impossible. All that massive energy is already there. It's been building up for years, sometimes centuries, as tectonic stress. All the solar current does, in theory, is act like that final, tiny little finger that just tips over the first domino. Here's another way to think about it. Just imagine a fault line, and it's stressed to, say, 99% of its breaking point. It's totally locked, but it is hanging on by a thread. It doesn't need a huge new force to make it slip. All it needs is that tiny, final 1% push. And this theory suggests that these geomagnetic currents from the sun, well, they could be that final critical push.
Okay, but remember, it wasn't just an earthquake. The theory has to explain the Kīlauea eruption too. So how on Earth could one single trigger from the sun affect two totally different systems, solid rock plates and a volcano?
Well, it turns out it all comes down to one word: conductivity. Basically, how well something carries an electrical current. So in a fault zone, these currents might weaken the bonds in rock that's already under a ton of stress, helping it slip. And in a volcano, well, magma is superconductive, so a jolt of electricity could easily disturb a pressurized magma chamber, maybe causing it to become unstable and release that pressure, erupt.
And this brings us back to that daylight factor. Remember how all this stuff went down on the side of the Earth facing the sun? That's not just a weird detail. It's actually a key piece of evidence for the theory. Why? Because the ionosphere gets way more electrically charged up when sunlight is hitting it. This creates a much better, more efficient path for those currents to travel from the sky down into the ground.
Okay, so this isn't just about looking back and trying to explain something weird that happened. What makes this whole thing so compelling is that the theory actually makes predictions, specific, testable predictions about what might happen next. And scientists are watching for it right now. This is literally science unfolding in real time.
See, that first solar flare, it didn't just send radiation our way. It also blasted out two giant clouds of solar plasma and magnetic fields. We call them coronal mass ejections, or CMEs. Now, the first one was just kind of a glancing blow, but the second one, which is much bigger, is forecasted to be a direct hit, and it's packing even more of a punch than the initial flare.
So what are the actual predictions? Well, there are two big ones. First, this incoming CME is expected to cause some geomagnetic storms over the next few days. Nothing apocalyptic, but noticeable. Second, and this is the really wild prediction, some scientists think there could be a rebound earthquake, a magnitude 5 or higher, at the antipodal point. What's that? It's the spot on the exact opposite side of the planet from the first quake. And they think it could happen within the next 72 hours. So you can see the stakes here. If we get that geomagnetic storm, and then a pretty significant earthquake happens, especially if it's anywhere near that opposite point on the globe, wow. The evidence for this whole Sun-Earth connection theory would become incredibly powerful. The next few days are a massive test. And that just leaves us with this one final, kind of mind-blowing thought. We usually think of our planet as this self-contained, closed system, right? But what if it's not? What if the ground we're standing on is intimately connected to the whims of our star, all part of one huge, interconnected electromagnetic system that, honestly, we're only just now beginning to understand?